we found, our turtles are coming from up north, and they're getting these barnacles that we know, because we measured barnacles each time they came, and we got a growth rate for them. We took that growth rate and we used it to back calculate when the turtles had first come into tropical waters. And what we found was that within 10 days of entering tropical waters, they start nesting. But we know that it takes about 30 days between mating and first nesting for most species of turtle, probably leatherbacks. So therefore, they must have been mating before they ever came down into the Caribbean. And that was the paradigm for a number of years. We published this in the 80s. And we finally figured out, at least that we knew they weren't mating in the tropics. Now comes the era of satellite telemetry. And this was a huge leap forward in our capacity to study turtles. This is a male. In fact, remember I said how fat they get? Look at that neck. That animal's like a linebacker. It's a real neck at all. We can now catch males, juveniles, and non-nesting females on the foraging grounds. And we use a big net. It's a big adventure. Put them on board, put satellite transmitters on them, and we tracked some males. And what we found is one of them actually came right down to here where I work in Trinidad, and he camped out here off the Lara Point. This is his locations from the satellite. Another one came down to the WIDECAST in Panama, an area called Cherokee, right out Cherokee. This is a colony of about 6,000 females. This is a colony of about 1,000 females. So the males kind of camped out off the nesting beach starting in about February. And this is one that came down between the islands of Grenada, St. Vincent, and St. Lucia. Small nesting colonies appear. Now here's the take home from this. The leatherback males come down in about February. The nesting season starts in about March on most of these colonies. It's just starting now. And so the males are coming down, they set up shop in advance of the females, maybe about the same time the females are coming down, and they wait for them. The two males at the WIDECAST in Trinidad are hanging out up in big nesting colonies, and they're hanging out where most of the females will pass by. So they have their opportunity to mate down there. If they come down to where they're small colonies, like this guy did, this said there's about 100 females here, about 50 females there, maybe about 150 females up there. He's got to move from island to island to find an opportunity to mate. This guy is literally bar hopping. Girls. Those other guys, they got it all wired. They just sit there and the girls come to them. So we've seen these two different patterns in the males, and then the males leave at the peak of the season. Yeah, exactly. Mating, the females will allow themselves to be mated maybe once or twice to begin the season, and they won't allow mating for the rest of the season because they store the sperm and they can fertilize each clutch as they need to. And so by May, the male's like, hey, this is boring, I gotta do something like that. At the peak of the nesting season, he leaves. And he goes back up north to go where the food's better. And the females continue to stay on through till July or August. And then they leave. So there's these two different strategies. The males will come back every year. The females come back every 2 to 3 or more years. So the male will come right back down here. In fact, that one off from Lara Point, Trinidad, has been down there now 3 times. Okay, we talked about a little bit the thrill of discovery and the creature of superlatives. Now let's talk about what's happening to the leatherback. And as a scientist, Kevin and I both were very idealistic when we were younger. We had this big goal that we were going to do for our careers something that was interesting, something that was fun and amazing, something that got us out there to work with animals, but also something that gave something back to the planet. And we've sort of stuck with that all these years. Leatherbacks are critically endangered. Now, what does critically endangered actually mean? We often use the word endangered in general terms to mean something's in trouble. But scientists use it from a slightly different perspective. Endangered and critically endangered actually have quantitative value. We actually measure categories for that. Endangered means an observed, estimated, inferred, or suspected reduction of at least 50% over the last 10 years or 3 generations, whichever is longer. So the population has dropped more than 50%. Critically endangered means 80% over the last 10 years or 3 generations, whichever is longer. Now, what does that mean for leatherback? The leatherback, the hawksbill, demonstrated critically endangered. That means their populations, their global populations, have dropped more than 80% in the last 3 generations. This is what their nesting populations look like in the Pacific. The largest population, one of the best known populations in the world on the peninsula of Malaysia and Terengganu. is virtually extinct today. It dropped from around 7,000 nests, which would be the same as about 1,000 females, in the 1960s, and had been dropping up to that point, down to pretty much nothing. Papua New Guinea, Irian giant, that population has also dropped, and the most dramatic one of all, 160,000 nests, or about 50 to 75,000 females, has dropped down to less than 1,000 females in the last 15 years in Mexico and Costa Rica. The Atlantic, the story's a little better. Our populations are tending to rise. This is Trinidad, this is French Guiana, Suriname. Weird thing going on here. This is French Guiana, this is Suriname. The beach is moving into French Guiana. It's on either side of the border, and it's moving, so the turtles are moving with it. But this population is generally increasing. The Northern Caribbean populations are generally increasing. The Atlantic's a much better story. But let's talk about Mexico so we can get a better understanding of why these populations are in such trouble globally. I started working here at Mexico Beach in about 1985, 1984, and worked through it into the mid-90s. This was the highest density, the largest nesting colony in the world. Mexico at that time sustained between 50 and 75,000 nesting females distributed among these main beaches and a whole bunch of minor beaches all the way up to the Baja Peninsula. By the year 2000, there were less than 1,000. This is Mexico Beach itself. You can see our numbers bouncing around here, the number of nests, 2,000, 4,000. This is typical. You would expect this kind of stuff because each year not all the females are nesting, so there's these cohort effects for some nests, some don't. But you get this bouncing around and you create an average through here. But look at what happened starting in about 1986, about 87, 88, 89. It started going down and it never came back. And I was working out there at that time. This year we thought, well, you know, it'll be back up the next year, right? Or maybe the next year, or maybe the next year. And by this time we're getting pretty panicky. Oh, went wrong. Why? We were out there working on the beaches, we were protecting all the eggs, we were protecting all the females. What went wrong?
They found out you were there.
Yeah. I have had that presented to me before, yes. I like to think that that's not the reason, but circumstances being what they are. So we really were stuck. We knew we had good protection going on the beaches. We had eggs being put in the hatcheries. We had the Mexican Marines camped on the beach with us to protect the turtles from poachers. And the Mexicans have been doing really good work since the late 1970s. So the protection was out there, and our population is still going down. It wasn't until we started doing satellite telemetry on them that we began to understand. We used to think when leatherbacks left Mexico, they went up north. And the reason we thought that is during the 80s, the high seas drift net fleets were catching leatherbacks up here. And so we thought, aha, our turtles are going up there. So the problem may lay up there. But again, remember, this was when satellite telemetry was at its infancy. Nobody had been doing it. And so I was able to develop this technique to put these satellite transmitters on them and track them. You've seen this figure before, but this was startling to us in the 1980s and early 1990s. We had no earthly idea these turtles were going down here. Now it gave us a new place to look for the problem. What we discovered was this. In the 1980s, Chile and Peru introduced gill netting as a way, drift gill nets as a way to catch swordfish. And many of you are probably familiar with the story of the collapsed fisheries down here. They wiped out their sardine fisheries in the 1970s and 80s. And the fishermen were starving. And they had this new technology called drift netting. And they thought, aha, small boats can carry drift nets out and catch a very high value catch in terms of swordfish right here in our waters. And so they started putting all these boats. And they went from, this is the amount of fishing effort measured in terms of days at sea. And you can see that at the beginning, about 1983, they had the equivalent of about 500 days at sea of fishing effort. No, about 3,500 days at sea of fishing effort. 3,500, about 4,000 days at sea of fishing effort. That is the number of days a fisherman fishes times the number of boats. By 1993, that effort had gone to 42,000 days of effort. They were capitalizing their fishery. They were buying the fishermen boats. They were buying the fishermen nets. They were putting them out